In this video, we're going to be talking about recursive functions. Specifically, we're going to define what is a recursive function. We're going to be talking about recursive notation, and we're going to do some examples where we calculate values defined by a recursive function. In other words, we're going to talk about what is a recursive function. We're going to be talking about how do you write a recursive function. And then we'll do some examples. We'll show how to actually use a recursive function in order to get numbers out of them. So first, let's define what a recursive function is. A recursive function is an equation where you define the next value based on values beforehand, based on previous values. Let's do a simple example. Let's say I asked you what would be the next y in this. I think most people would say that their answer is 19. If I ask you, how did you get 19? You'd probably say something along the lines of, oh, I noticed it was plus 3, plus 3, plus 3. And so then I did 16 plus 3 to get my 19. Right there, that was recursive thinking. You used a previous value to get the next value. Okay, so if a recursive function is an equation that uses previous values, let's talk about how do you write a recursive function. This word notation is basically just how do you write something. Okay, so let's use this as our example. So this right here is a recursive function. This is recursive notation. This is how you write a recursive function. So how do you read this? Well, one way of thinking about this is reading it from right to left. So quick little thing, sort of a reminder. This right here, this f of x, this right here is your y value when x is equal to whatever number you put in there. So this f of x is basically like your y. Okay, now in terms of reading this, you can think of this as a right column and a sort of left column. So if you read this right to left, you can think of this as when x is equal to this, then your y is equal to this. You'll also kind of notice there are sort of two different rows here. It's actually two different sort of parts, two different equations almost. There's the top one and then there's the bottom one. Looking at the very top one, it says here when x is equal to 0, then my y is equal to 1. So when x equals 0, then my y is equal to 1. When my x is bigger than 0, then my y is equal to this equation here. pause the video to take notes. Hit play when you're ready to continue. So this is one way of thinking about it. Let's now look more closely at this second line right here. Okay, this is the exact same equation as we just had. So once again, this right here, that is your y value. I want to talk about this sort of part right there. If you notice they look similar to each other. This right here is your y value. This right here is the y value 1 before. One before this one. That's what that -1 is indicating. Another way you can just think of this, if this is too many words for you, you can just think of that piece right there as meaning the previous y. Pause here. Hit play when you're ready to continue. Okay, so let's look at this. Okay. Once again, this is still the exact same equation. We're now just going to look at the values for this equation. So this is moving on to this third point. How do we get values from our recursive function? Okay. So like I was saying when we first started this, when x equals 0, your y is equal to 1. So let's mark that into our table. So I just made a table with this exact same equation. So when x equals 0, y is equal to 1. All right, and that was the green one we were just looking at. Okay, well, obviously the next x is going to be x equals 1. So let's find out when x equals 1, what is my y? What is my f of x? So we're right now looking for f of 1. So this is when x equals 1. Okay. So like I was saying before, this right here, one way of thinking about this piece right here, this is the previous y. So if right now I'm looking for this y right here, then that would make this one right here my previous y. So my previous y is equal to 1. All right. So this is previous y plus 2x. And my x is equal to 1 right now. So this is my 2x is 2 times 1. And then minus 1. So therefore, my f of 1, or my y when x equals 1, is 1 plus 2 times 1 minus 1. 2 times 1 is 2, so 1 plus 2 minus 1 equals 2. So let's write that into our table. When x equals 1, y is 2, or f of x is 2. If this way of thinking, where you're thinking about this as your previous y, if that doesn't really, that doesn't make sense in your head, if that doesn't feel satisfactory, another way we can just do this is let's plug in x equals 1 into here. So all I'm going to do is I'm just going to change all of my x's to 1. So I changed that x to 1. So now I'm going to change this x to 1. And I'll change this x to a 1. When you're substituting in for a variable, it is best to put it in parentheses like I did here. I should have actually put this number 1 in a parentheses, but I kind of thought having all those parentheses in here would actually make it harder to understand. So I've changed all the x's into 1. So let's evaluate this. F of parentheses 1 minus 1 is 0. So this is f of 0. I'm just going to leave the rest of this alone. Okay, and f of 0, that is my y value when x equals 0. So my y value when x equals 0 is 1, which is right there. So you can either jump straight from here to here, if you can think of this right here as your previous y, or your y1 beforehand. Or if that doesn't work in your head, just change the x's into whatever number you want and, simplify going down. Right? Pause here. Take notes. When you're ready to continue, hit play. All right, so let's continue. Let's find the next y. So let's do f of 2, or your y value when x equals 2. I'm going to use that idea of previous y. So f of 2 is equal to my previous y. So equal to my previous y. So x equals 2. I'm looking for this one right now. And my previous y is 2. And then plus 2x minus 1. My x is, currently my x is 2. So f of 2 simplifies to 2 times 2 is 4. So 2 plus 4 minus 1 is 5. So my next y is equal to 5. I'm going to do one more. Before I do that, pause and take notes if you'd like. Hit play when you're ready to continue. Okay. That is still the same equation up top. I'm just doing now f of 3. Because now my x is equal to 3. I'm trying to find this one. So f of 3 is equal to your previous y, which in this case is this 5 right here. So that is a 5 right there, plus 2 times x minus 1. My x right now is a 3. So let's simplify that. Two times 3 is 6. 5 plus 6 minus 1 is 10. So that is 10. Okay. Pause here. Hit play when you're ready to continue. All right, let's do a different recursive function. Done the same one a whole bunch of times. Let's try a different one. So let's try this one right here. All right, so notice that we don't have x's here. Instead of an x, they're using n's. But it basically functions exactly like an x. So this, instead of x, I'm going to put n there. And instead of f of x, I'm using g of n. But still, that's basically just your y. All right. So here, remember, each row is basically its own equation. This first row, it only happens when n equals 2. So this is n equals 2. Your g of n, or your y, is equal to 4. Let's put that into our table. 2, 4. All right. Next one. Our next row only happens when n equals 3. And when n equals 3, my y, or my g of n, is 5. So this, when n equals 3, g of n is 5. All right. So now, since I've already done n equals 2, n equals 3, the next n is 4. And 4 is bigger than 3, so I have to use this line right here. All right, n equals 4. So now I'm looking for this one. Okay, now this looks slightly different than what you've seen before, but it follows the same sort of pattern. So this right here, just to remind us, this is your y value. This right here is your y value, but 1 before. Because you have that 1 there, and the minus is like before. All right. You might be able to guess what this means right here. This is also your y value. The only difference is this is your y value 2 before. So when you're using an n bigger than 3, it's equal Your y value is equal to your y value 1 before plus your y value 2 before. Let's do an example. And reminder, we're right now doing n equals 4. So your g of 4 is equal to your y value that is 1 before that. So g of 4 is right here. 1 before is this 5. Plus your y value that is 2 before. So I'm still looking at this y, and 2 before is this 4 right here. Okay, so let's simplify. Your g of 4 is equal to 5 plus 4, which is obviously 9. So g of 4 equals 9. All right, pause here, take notes, hit play when you're ready to continue. All right, let's do one more. Your g of 5 well, now I'm doing n equals 5, so I'm looking for this y right there. Okay, and your g of 5 is equal to your y value 1 before. What is 1 before this one? It is the 9. Plus your y value that was 2 before. So if this is the one we're looking for, 2 before is that 5 right there. All right, so your g of 5 is equal to, g of 5 is equal to 9 plus 5, which is 14. There you go. And you can continue going down more and more if you want. Pause to take notes.